Right, here's our top module. We start with a display data bus and then our inputs. And then we also define a mux selector input and also a clock. Here we have our wires for our buses to wire together in our instantiations of our modules. So here we have our decoder, so our unsigned decoder module, next our twos decoder module, and then our mux. Connecting all of them together using our buses over here, a 10-wire bus. So looking at the module itself, we'll start with the unsigned decoder. Here it is. Again, all we do is just create a whole bus of inputs and outputs, instantiate them on the top, and then compare this data with we compare it with the case from 0 to 16, and then depending on our data, we send out our outputs to be this 10-bit code for a 7-bit register, or a 7-segment register. If not, then we make it a default case of X to avoid any unwanted latches. This works similarly to the 2's decoder, just a different data line. Bam. Okay. Here's our mux. So for our mux, we use a tritary command. Depending on if our selector is on or off. If it is on, we click 2's. If it is off, we stay with unsigned. So back to our top module. We take our input data, then we get the unsigned data out. Input data also goes into the 2's decoder, then we get 2's data out. Then we send these both into our mux, and depending on our mux selector, we pick which mux output it should be. Here in our always positive clock edge, so this ensures that our data only ever changes on the positive edge of the clock. So if on every positive edge of the clock, we send our mux output right here, which holds the current display data, either 2's or unsigned, into the actual display data. So here's our waves. For every we make our 0, so this is every value of binary, every value in a binary we can have. Our clock running on 100, clock alternating, and then our mux selector. So we choose between 2's complement and the unsigned complement. And taking an inside look. Well, at the start, we don't have any input because we don't have a rising edge of the clock yet. So at the start of the rising edge of the clock, we first read in the new input right here. And you can compare this with our actual input of 1101, and you can see that our input up here is expected. So mux selector is 1, which means we're choosing a 2's comp. Use 1, so 1101 for a 2's comp. 1101 means 1001, 00111. And back to our wave, 101, 1011. Or is it reading this one? Oh, let me check. Hey, whatever. Check it. The case statements work and stuff. And so they always update on the positive logic clock, so that's why it only ever works on the rising edge of the clock. And that works for all the values down.